Alright, so I have Camtasia opened, and I've already collected data for this. I'm just going to review with you just the basics here, and then let's look at the analysis that you should do. We went out to the gym and took a few shots, and in our second shot she made a swish, hit it right in the basket, and I've advanced my video to that point, which is what you want to do, is advance your video to the point using your tools down here. This advances frame by frame. Or you can grab your slider bar here and advance roughly to the point, then go frame by frame. Because I actually want to advance to the point where she's just going to release the ball. And I actually chose it as that point. In fact, you can see my first data point that I plotted right there. When you select that point, that's probably the best time to set up your axes. Typically, you'd set up your axes going through the ball, and this one's moving to the left. I actually, for this case, I chose my basketball net as the x-axis and the y-axis origin. Along the ground at her feet, you notice that's where her feet are touching in between her feet. The distance between the floor and the hoop should be 10 feet, and I use the ruler toolbar to actually measure that out. In your pumpkin videos, we have people of known height that is in the label of the video that you can use while they're standing in the plane of the motion. You definitely don't want to choose somebody who's not in the plane of the motion. For example, we've got Ryan back here. He's standing back probably 5-10 feet further back. So if I were to use his feet, I don't know, let's say he was 6 feet tall. If he's 6 feet tall, but he's standing back from our frame of reference, I'm going to measure this as 6 feet, but anything forward of that is going to look taller, and that'll make all these distances where the ball is actually moving larger than they actually are. So you have to really be careful about having a known height in your plane of motion. So we've got that set up. Remember, the other thing you need to do, if you're doing a slow-mo video, or if you're just doing a regular motion video, which is 30 frames per second, you need to adjust your movie options. For all videos, you need to click off on the first VA point defines the movie time 0, because that's going to set your first point to 0. You definitely want to do that, or else you're going to have a rough time getting equations out of it otherwise. The other feature I'm going to select, if you are doing slow-mo, you would override the frame rate to whatever the frame rate your slow-mo video is. And actually, slow-mo video is actually a high-speed video. Apple's iPhone 5 had a maximum rate of 120 frames per second, and the Apple 6 runs at 240 frames per second. But it's user selectable, so you really do have to know what the frame rate is to be able to put the correct number in here. The phones that we were using were 240 frames per second. If your numbers are off the end, that might be the reason why. So click on that, put in 120 or 240 based on which iPhone you have. The next thing we want to look at is how we want to advance the frames. When I actually click down these data points, I can set up to go frame by frame, or I can skip frames. For a really long video that's maybe a minute long, a minute times 30 seconds is 1,800 data points. I don't really want 1,800 data points, and so I would maybe select maybe every 30 frames I'd pick a spot. But this is a very short video. We're only going to have a second or two of data here, and so 1 frame per second on 30 frame rate video is fine. If it's 240 frames per second, you're going to get a couple hundred data points. And so what I'd suggest for a very short video like this, where you're a second or so in the air, just divide it by 8. So put an 8 in here, and then it'll essentially get you back to 30 frames per second, because it'll skip every 8th frame. But the clarity of the video is going to be much better for you to plot. Once you set that up, go ahead and then you can start using your tool up here to actually start setting your data points. And I already set my first one here, and I'll just step you through so you can see my other ones that I chose. If you look at this video, I'm actually holding this by hand because you can see motion in the background here. And of course, that's going to mess up my data collection a little bit. And so here's my last point in here. And notice at this point I hit the basket, the back end of it. And actually you can see this tail off here. So that's going to throw my data off a little bit at the end as well. So there's my data. And as you can see, as you do it, it will pop up on a screen behind the video. And your data will show up as it's collected. And you'll notice as well on the data, you have data to the right here. It also automatically calculates your X and Y velocities. I don't think it will automatically plot it, but you can just add another graph in. Now on your initial setup, this X versus T and Y versus T graph will be full screen, but you can just click on it and grab the corners and you can resize it. And I'll just split this half and half. I'll put a position versus time up top, and the lower half I'll put a velocity versus time. And all we have to do that is we can insert a new graph right here, top item, and here's a new graph. It automatically looks at your data and thinks you'd want probably plot your other data, and it's pretty close on what it's guessing here. What we're missing here is it actually plotted for us our y velocity. We'd also like our x velocity plotted, and that's easy enough to do. I can just right click on this. I can pick up graph options, and I can pick up the x velocity as well and hit done. So the next thing I'd like you to do is to break these graphs down into, on the left side, let's do an x versus t and a vx versus t, and let's isolate and move the y values over to two separate graphs on the right side, just like your prediction activity did, so we can compare them apples to apples. So I'm just going to make some room over here. I'm going to divide this space up into quarters now. And I'll insert some new graphs here. So since it's already giving me a velocity versus time, and it's a y velocity, which is nice because that's what I want over there, and I'm going to try to even up the spaces. In fact, I don't really need this data as much now. I'm going to shift this over a little bit to the right, give my graphs a little bit more space. So I'm just shifting these so they fit about a quarter of the screen each. I'm going to overlap a little bit. I don't need this ending data. And let me insert one more graph here. And make sure our time scales line up nicely. That's about right. Now we need to adjust our graphs here. Here, let's do on the left side, we're going to do x. We're going to keep the two red graphs here. We've got the x and the vx, and we want to get rid of the vy. And you can do it pretty easily. If you click onto these, you can either go into the graphs and you can edit the graphs. I can right click on it and come up with graph options. The other thing you can do is I can actually click on these titles here, and it'll actually ask what you want to plot. And I'd only really like to plot the x velocity. It just got rid of all my blue dots. Here's all my x dots, but you notice the other thing it did, it adjusted my scale on me. We can readjust the scale. I'll do that in a second. Up here, let's get rid of our y values. We only want to plot x up here. Alright, so those are our x values. And that scale is okay, so they did a good job on that scale. So let's adjust this scale. So I'm going to click on this graph, right click on this, hit the graph options, and I can adjust my scale here. On the left side, this is for my vertical axis. This information down here is for my horizontal axis. Horizontal axis is fine, 0 to 1.2 seconds. You can see that showing up here as an auto scale. I want to get rid of this auto scale here for the y-axis, which is our vx axis. And it's actually automatically picked negative 8.8 to negative 12.4. I'm just going to do that manually. And remember, this is a negative scale that we're going up. So this is a negative slope here. So I'm going to start at positive 1 maybe. I'll keep their negative 12.4 on there. And that's not a bad scale. I'm going to actually shift this a little bit more. So you can see my 0 up here, and here's like negative 12, but it looks like we might be cutting off our data a little bit. Let me just go to negative 15 instead. And that's a good scale. The graph over here should be actually a y-axis. So we're going to click that over to y. So as you can see, they auto-scaled the y-scale as well to fit just the data, and it cropped out any blank areas. I would like to show the 0, 0, the origin on this. As you can see, Morgan started shooting this from a little over 7 feet. It went up into the air, and then it came back down and hit the basket around 10 feet. So 10 feet actually is right in the middle here. So that's where it actually entered the basket, and this is a couple shots. This is where it slammed into the net and bent our data a little bit. You can see that happening down here. So I'm going to adjust the scale just so we can see the 0 and see this true to scale option here. So what I'm going to do is I'm going to, once again, this is for the y-axis and this is for the t-axis. The t-axis is fine, they match. And I'm going to click off, actually let me try auto scaling from 0 here, and I bet you that'll take care of me. There we go. So there we are. There's our graphs. Now on these graphs, what can you do with these graphs? What you should do at this point is to use your analytical tools. What can we do on a position versus time graph? Find slopes. What can we do on a velocity versus time graph? Find slopes, find areas. I'll demonstrate those techniques on one of these graphs. So I'm going to select this data in my upper left graph here for my x versus t. just click and hold and select the data. You want to make sure you capture all your data. You can see when it's captured, but everything's highlighted over here. You might not want to capture all of your data though. For example, when it hit the net over on my y versus t, that data is going to be skewed a little bit, so I'd probably want to leave that data point off, for example. So here's my data. I would like to do a line of best fit through here. Here's a line of best fit, linear fit function, but it's, I think, better, generally speaking, to use this curve fitting feature, because then you can pick any shape that you would like to go through here, any mathematical equation. And so you can see we're going to do a linear fit. On our parabola, we'd use a quadratic. I'm going to do it automatically. We don't have to do a time offset because we have our time set to 0. And I'm going to go ahead and try a fit. And there's my fit. It's showing me right here with my numbers. I'm going to hit OK on that. That looks good. And there are my values. And now you can interpret those. All right. Our slope is negative 11.68 feet per second. Well, look down below here. Negative 11.8 is right here. So that's like a horizontal line coming through there. Use this tools on each of these 4 graphs, interpret the values. The other thing we can do, of course, is we can take our data. Let me just highlight the same data again. We can actually calculate the area trapped, quote unquote, under a curve. And we're going to use what's called the integral function. That's calculus for finding the area under a curve, or trapped between the curve and your horizontal axis. So I highlighted my data. I click on this. Boom. There's my area. You can see here's my area up above collected, and here's a little bit of area below. And here's my analysis. It shows me my integral for this area I selected here is 7.125 seconds times feet. Meaningless. I'm not sure what those values mean. All right, but certainly on the graphs down below, that wouldn't be meaningless. And on the graphs down below, I'd like you to find those areas and interpret that. On this graph here, I would like you to split the area into 2 pieces. You've got the area above the axis, the area below the axis, and interpret that meaning. And finally, what you need to do at the end of this is write up a little lab report, 1 page. I don't want to go beyond 1 page. You're going to attach your little sketch predictions you did, and you can print this page out from LoggerPro to show your analysis you did, and then give a discussion of the theory behind 2D motion and your expectations for a ball being tossed in 2D, and then here's your analytical side of it, and show how they match or don't match. Explain any variations you got.